Guys, welcome to the Data Structures and Algorithm course brought to you by Asha Akanksha Foundation. So in today's lecture, we will talk about recursion. Recursion is a process in which the function calls itself directly or indirectly. In recursion, we divide the problem into subproblems and try to achieve the result by using the same function again and again. So in the structure of the code, we call the same method directly or indirectly and decompose the problem into similar subproblems. And we should always remember, sorry for the notification. So we also need to handle the base case so as the recursion calls will terminate somewhere. Otherwise, it will gonna show us the stack overflow error. We will try to understand this concept using some examples, right? So think about a problem in which we have to collect 1 million rupees for the charity. How can you approach that problem, or how can you solve this problem? You can directly ask 1,000 friends to donate rupees 1,000 each, right? But it is not possible for all the 1,000 friends to donate 1,000 rupees each. But the thing you know is that most people are willing to donate 100 rupees. So there can be two solutions for this problem. One is iterative solution, like uh, without using the same thing again repetitively. So we can directly ask 10,000 people for 100 rupees. So that counts for 1 million rupees, right? So but the other alternative solution is recursive solution. If we divide this task and into 10 similar peoples, like we tell the 10 volunteers to uh, 10 volunteers to achieve this task of collecting 100 rupees from collecting 100 rupees from every person and collecting a total of one tenth of the amount of money uh, that we have been asked to raise. Like in this question, we have been asked 1 million rupees, so one tenth for amount for 10,000 rupees. So we will assign this task to 10 people of collecting 10,000 rupees from people, and at the last we will combine all the money collected from all the volunteers. So that will give us 1 million rupees, right? So if we think of it in the code will look something like this, right? If n is less than 100, what do you mean by this? If n is less than 100 means um, like people are donating less than 100 rupees. We can collect the money from a single donor because every person is willing to donate at least 100 rupees. Otherwise, we, so yes, we'll find 10 volunteers and assign the task of collecting 10,000 rupees, or you can say the total amount divided by 10 rupees, and then collect all the money raised by all the volunteers. That would give us the total money. So we are in this question. What are we are basically doing is assigning the similar task to every person. Like we have given the task of collecting the money to 10 volunteers. So the task is basically same, but we are calling this task again and again. So that's why this is a recursive solution. You can see over here that we have called this collect contribution function, which is doing the task of collecting money from people. So we call the collect contribution function, but over here we are collecting only n by 10 rupees and not n rupees, because we are distributing this task into some similar sub problems. Okay, so I hope you understand the basic idea of recursion through this problem. So going ahead, we'll try to solve so we'll try to build an idea how to solve a problem through recursion. Okay, so Ooh, recursive solution for finding a recursive solution, you just have to break down a problem into similar subproblems. Okay, so basically you are decomposing a problem into similar subproblems which you think are doing the same task only. But at in the a very important task in finding a recursive solution is to find the base case, because without base case recursion will not work. So base case is basically a situation when the function will return itself. Like in the above case, if the amount of money is less than 100, we will return, because it is given that every person is willing to donate at least 100 rupees. So there is no question of asking for less money from them. So that is the base case over here. So let's talk about another example for the recursion, which is very famous. That is the factorial problem. So let's talk about what is factorial. Factorial is just the multiplication, is the continuous multiplication of that number with the other smaller natural numbers. Like 4 factorials is 4 cross 3 cross 2 cross 1. So how will you approach this problem? So if you see carefully over here, that 4 factorial is nothing but 4 multiplied by 3 factorial. Alright. So what do you mean by this? So if we think of factorial as a function over here, like this sign exclamatory mark. So what we are doing is multiplying this number which is passed into this factorial function with the smaller number. Like over here it is 3. So multiplying this with the smaller number factorial will give us the required result. And we can decompose this problem also into similar subproblems, like multiplying 3 with 2 factorial, and then we can do this 2 factorial into 2 cross 1 factorial. Um, and 1 cross 1 factorial is we can do it in 1 cross 0 factorial, but we have to stop over here because negative numbers do not have factorial. So this will form a base case for us over here, because 0 factorial is 1. So if we get 0 in the function, we will definitely gonna return 0. So this will serve as the base case over here for this function. So this is the mathematical formula for the factorial. So if you don't know about the factorial, you can just take a look at this. So let's try to code this factorial function. So this is the basic code. I will explain it one by line by line. So in the function, the first thing that we have to do is find a base case. So as we talked about the base case of factorial function over here, what was the base case over here? The base case for this function was our 0 factorial, because if we encounter 0 in the factorial function, we will just gonna return 1, because we cannot decompose that, because we cannot decompose further. Like we cannot go from a 0 to -1, because -1 factorial is not defined. So if we found 0, we just return 1 over there. Otherwise we will decompose the problem into sub problems. Like we'll do n minus 1, what we got over here, n, we will do n minus 1, and we'll find the factorial of this over here. Like, you can see we are finding the factorial of n minus over here and storing this factorial into a variable called subfact. Now we will multiply that number which we got in the function with the factorial of n minus 1. We will gonna return this, and that is the answer. So let's take an example of factorial 4, which we have shown over here. If we can see, if we pass n is equals to 4, it will not go in this if condition, because n is not equals to 0. It will go in the else condition. Sub n would be equal to 3, and subfact will be equal to factorial of 3. Then it will gonna again call the factorial function. It will not go in the if condition because it is not equal to 0. Sub n will be equal to 2. Subfact will be equal to factorial of 2. It will again go in the factorial function. Sub n will be equal to 1, and subfact will be equal to factorial of 0. Now here n is equals to 0, so it will gonna return 1. So factorial of 1 subfact, which you can say is stored in the subfact variable, factorial of 1 would be equal to 1, and it will gonna return recursively. So we will get something like this. See, we have recursively called for 4 factorial. It has gone to 3 factorial, then it has gone to 2 factorial, then it has gone to 1 factorial, and from 0 factorial we have got 1. So 1 is multiplied over here, then it would gonna multiply with 2, then it would gonna multiply with 3, and then it will gonna multiply with 4, and finally we will get the final answer. So I hope you understand the basic idea of recursion through this problem. So let's go ahead with the another good example in the recursion is raising a number to the power. So I guess you know the basic exponential functions like a to the power of n. We can decompose a to the power of n as a multiplied by a to the power of n minus 1. This is basically a very generic, or you can say a very basic exponential identity that we can write, and that in multiplication the powers are added. So if we see a to the power of 1 multiplied by a to the power of n minus 1, it will gonna give us a to the power of n only. And but you have to find a base case over here also. So yeah, I guess most of you know that a to the power of 0 is equals to 1, that power of a number to the that power number power to 0 is equals to 1. This is a basic idea which we're going to apply it over here. So we will call a function, we will define a function power which takes two variables, double a and a one int. And don't worry about double, we have covered this in our Java basics. You can refer to the video which is uploaded on the Asha Akanksha Foundation YouTube channel, or you can also search for it on the Google. So we have written over here the base case, like if n is equals to 0, return 1, because we have defined this as the base case. If power is equals to 0, we will directly return 1. Otherwise we will call the function for n minus 1 power. We have got our a, but we have decreased the power by 1 and multiplied that number with a a. So this will be a recursive function for the power. Let's take a look at it step by step. If we call this function for a to the power of 4, in which a will be equal to a and n will become 4. So it will go over, it will not go in the if condition because n is not equal to 0. Sorry, my battery is running low. Okay. Uh, it will uh, it will call the function for a cube and then multiply with a, and again recursive it will call the function for a square, then it will call for a to the power of 1, then it will call for a to the power of 0. But in this function call we encounter the if condition because n is equals to 0 and will directly return 1. So we have got this 1, then it will multiply with this a, this a, this a, this a, and then ultimately we will gonna get the final answer which is equal to a to the power of 4. Okay, so now we will talk about what happens behind the scene in a recursive method. When we call a recursive function, and it goes through all the statements which are written in the code, and as soon as it finds another call to the function, it stores a temporary local variable in the memory, which is also known as which is a local variable in, it is stored in the memory, and it will gonna call the function from the start. It iterates to the function. As soon as it finds another call to the function, it creates another local variable and store it in the memory, which is in the top of that previous variable. So as soon as it finds another call to the function, it stores a local variable on the top of the another. So you can think of it like a stack. It keeps on building on the top of the another. So whenever a function returns, the top of the function becomes empty and the previous top will become the new top. So that is why it is a stack based call, which is followed in the recursion. So now we will compare what is the basic difference in the recursion and iteration. So in general talking, most recursive solutions have a corresponding iterative solution because uh, it is recursion is nothing but a stack-based implementation of our iteration of a iterative solution. For example, we can also compute the factorial of n, which we have discussed in the which we have discussed before with the help of a loop also. So every recursive solution can be substituted with a loop. Uh, now we will, but the backside of the recursion is that it has a function overhead, which because we have to call function again and again, so it stores the every call of the function in the memory for some time, and then when it returns, then it deallocates the memory only. So as we can see over here, it is written that every time a recursive call is made, the parameters need to be stored in the fixed place in the memory. As soon as we return from there, it the variable got deallocated. So it is a very cumbersome process, or you can say it is a very memory taking process. So that's why recursive solutions are more expensive in terms of memory than their corresponding iterative solutions. But the good side about the recursion is the solutions look more simpler and look more compact. So that's why people used to prefer recursion, but in terms of efficiency, it is not something which you should look up to. But yeah, for the beginner, to make the code simpler, recursion is a good go-to. But there are many exceptions in which only recursive solutions are possible. We will talk about that those problems in the further course. So uh, that's it for this lecture. And in the next lecture, we will talk about arrays. So if you have any questions regarding the recursion concept, you can comment down below, or you can also reach out to us at our instant FP page. So see you in the next video. Till then, bye bye. Happy learning. Thank you.